I'm RobinaShaheen, ROBINA, space SHAHEEN.
And your area of focus?
I'm physical chemist, so I study meteorites from Mars or somewhere else.
Hi, Robina. I'm sitting here with RobinaShaheen. She is one of the foremost researchers in the field of, I guess it's molecular geology, and we're studying rocks to see whether they have evidence of life on other planets, which is a very fascinating field. What are we looking for when we're studying a rock to see if there's signs of life? What specifically will let us know whether there is life on other planets?
So in that regard, I find it's very exciting once people think maybe some aliens living in that rock. I see the basic structure, the very basic molecule that forms the initial, maybe a bacteria or any virus. So I look for those basic building blocks. That's what's important to me. And if we find that, we might have the opportunity to progress based on that, to find more complex life. But the bacteria and the single cells animals are the simplest one.
And where are you finding rocks that you say?
I find these rocks in Antarctic. The reason because, you see, it's a huge area with white ice, and if any rock comes from the space, it's just lying there as a black spot, and you can easily pick it up. So I brought this meteorite, Allen Hill. So Allen Hill is a place in Antarctic, and scientists, they have this naming procedure. Wherever the rock is found, they give it to the name to that rock. And this particular rock is very, very important because it's 4 billion year old. And scientists back in 1996 announced that there is an evidence of life in this rock. So that was very intriguing. And it was a great news because it sparked a lot of interest to go to Mars. And so we have all these suits of equipments. They are trying to find life over there on the Mars.
So did there turn out to be life on this rock?
Because this rock had been in Antarctic for 1100 years. It's a long time, so it stayed on the ice. Unluckily, there was some contamination from our own planet in the little cracks. So that was somehow people misunderstood as coming from Mars. And the beauty of my research is I use isotopes. They are like fingerprints of living processes or non-living processes. And I can isolate if these organics or these tiny bacteria-like structure, they were living or non-living.
And in this case,
They were actually from Mars, but they were not produced by the living organism. There was a small contamination from Antarctic, and some local bugs, they penetrated, but based on isotope, I could isolate them. And the rest of the things, they were produced not in the living organism, but outside with direct interaction with the atmosphere.
So do you believe that we are close to finding life, or that life does exist outside Earth?
Our biggest hope is Mars, because it has had condition very much similar to Earth right now, because a large amount of the atmosphere has gone. So we are trying to, like curiosity, is digging under the ice to see if tiny bacteria or something like that might have hidden under the ice. And also, for us, it's more important to see what were the conditions necessary to begin the life, because that's a very critical question. And if we find it maybe on moons of the Jupiter, on Mars or anywhere, then we will have a whole suite of research going on, how the life started on our beautiful planet. Like I brought this picture where we have some simple molecules and the plants and beautiful life activities going on, and the humans are enjoying this intricacy of life in a beautiful way. And if we find how it started, that would be a great triumph for all of us.
Okay, thank you, Robina.